Thank you for coming out to the Space Exploration Celebration. Today we've got a distinguished panel to start talking about NASA in the future and where we're going with NASA in the future. Many of you were out last weekend at the end of the shuttle celebration, where over 3,500 NASA employees came to celebrate the end of the shuttle. And many of you saw the last shuttle launch when 1 million people sat down in Florida and watched the shuttle take off, and 1 million people sat there in awe. It was a great sight. And then 2 months ago, I had the opportunity to be at the Paris Air Show, the largest aviation show in the world. And one of the most interesting things to see at that Paris Air Show, and if you would put up the first slide, please, was the People's Republic of China, their exhibition that was sitting right there in the middle of the air show talking about their space program. Next slide, please. This kind of walks you through what they had on their slides. And if you will notice, I, as an American, found it very, very interesting that we're sitting in Paris, France, where they speak French. We're looking at a Chinese display that is not in Chinese. And it's obvious when you start looking at it that the audience that they're intending to go to is not to the Chinese people to convince them that they need to have a space program, but it's to somebody else. And this is what was put forward to us. We had the whole program was flipped through and quickly said, this is where we're going as a nation. This is our program. This is what we will do in the future. So today we brought together what I would call a space council, a group who can look at where we're going in the future, and a group that can talk to us about the complexity of what we're facing as a country when we look at a very complex issue of putting a man back into space, into deep space, how we afford it, how we finance it, and why we need to do it. And one of the things that we can do out of this is we hope to shed some light on where we need to go. We've got with us today, we've got Bud Cramer, our former House of Representatives member for the Alabama's 5th District for the past 18 years. We have Steve Cook, Director of Space Technologies at Dynetics. We have Mike Griffin, who serves as the King-McDonald Eminent Scholar and Professor at UAHuntsville, and he's a former Director of NASA, former Administrator of NASA. We have Jim Chilton, Vice President and Program Manager for Exploration and Launch Systems at the Boeing Company, and Shar Hendricks, President of the Hendricks Groups here in Huntsville. And one of the things we'd like to do today is to have a conversation about where we are, where we need to go, and what it's going to take to get there. And we'd like to start off with Congressman Cramer talking about where Congress is, where we are in the Congressional process, and what Congress has taught to us, has given us permission to do with the space program. Bud?
Thank you, Mayor, and to my colleagues on the panel. I'm honored to serve with you today and to attempt to offer some information that maybe shed some context to what we're going through here in this community of North Alabama as we await sort of finalization of many NASA-authorized programs that we guard for the Marshall Space Flight Center, but we rise above that and to say that so goes NASA, so goes a significant part of the R&D investment that this country spends in taxpayer money. I'm pleased to say that I'm a former member of Congress. This would be a very tough time to be there right now. I did put in 18 years during which I lived and breathed almost every day NASA's challenges, NASA's issues. What I would like to do is take just a few minutes to take you back to the past to let you understand the framework that I think is left for us now, and then to quickly come forward with where I see the challenges for right now. When I was there as a new member of Congress, I joined with other House members from space center districts from around the country. We often didn't see program issues the same way. In fact, I would from time to time think that I needed to watch the Texas folks as they looked after their issues and make sure that we weren't sacrificed in that process. But all things considered, we rose above that, and we formed a very organized group of House members that interacted with NASA headquarters, with the contractor community, and what we would eventually call the House Action Team. And a lot of us had key committee assignments, but geographically we were mainly from center districts from around the country, and we would plot from time to time to make sure that the administration, headquarters, other members were educated about why NASA funding needed to be at the level that it was and why certain programs needed to be preserved as well. So we struggled through many years together. Currently, what I'd like you to know is that there seems to me to be a divide between NASA headquarters and the Congress. That can happen. The administration proposes budgets. I like to say Congress disposes of budgets. The Congress reacts to what the president presents, and then they begin threading the needles, and there's certain realities there. You have our delegation, our congressional delegation, which I was a part of. In fact, I rose to be the senior House member in that delegation, and as a delegation of 7 House members and 2 senators, we were very experienced at interacting with NASA headquarters. This delegation is still experienced and is aggressive about interacting with NASA headquarters. I served Mike Griffin there. Admiral Truly was the first NASA administrator that I interacted with, and then Dan Golden was there for so many years. I thought Dan Golden was always going to be there after a while. Then we had Sean O'Keefe and we had Mike Griffin as well. We as a delegation would bend over backwards to try to reach out, whether we saw the issues the same or not, to make sure that we compared ends and that we at least tried to find out where we were coming from. As I see things right now, we've had a new president. I remember when George Bush became president and we transitioned from NASA visions and programs from the Clinton administration to the Bush administration. It seemed like it took too long to kind of crank up new programs, to wind down other programs. Our workforce then here was demoralized, worried, scared. Our center leadership was worried about how to transition employees in certain programs, and that's hard to do. We're going through an even tougher time right now, in my opinion, as we look at the wind down of the shuttle, a human space exploration, the rise of commercial, very legitimate commercial involvement in space exploration issues. You've had our fight with the delegation to kind of preserve the elements of Constellation. You had a NASA authorization bill that was passed in the fall of 2010, the hard way, at the last minute. The Senate and the House came together, which authorized a certain level of NASA funding, but it preserved the heavy lift SLS program, and it authorized funding at a particular level. Then we get into the 2011 continuing resolution with a level of funding that the Congress provided, and then we had the 2012 budget that we're now working through. We all know that on the House side, in the Commerce, Science, Justice Committee, that the budget that they approved back in July was much less than what the president authorized. This is a brutal time of year for budgets, and it's not going to get any easier as we look after Labor Day to when Congress picks up the pieces and looks at our economic challenges in general. We've got a super committee that's now been named, and their vision of cuts and their process for coming up with cuts. I don't necessarily expect that super committee to be real program specific, but you better believe that what they begin to decide, what they eventually decide, will have impact on the finalization of this Commerce, Justice, Science bill that started in the House. It's got to finish in the Senate as well. So the whole question, Mayor, becomes whether we get involved in another CR and where funding goes. My quick word of warning is that NASA headquarters, with their internal struggle with OMB, that they've got to put definition, they've got to put meat on the bone with regard to heavy lift and SLS, and give us some details about that so that we as a community can understand our roles and missions in that. Otherwise, you're going to have the Kay Baileys that look to Richard Shelby, the Barbara Mikulskis that look to Richard Shelby, the powers that be in significant positions up there reacting to this in a way that's not so NASA headquarters friendly.
Thank you, Bud. We'll take comments from each of the panelists and then take questions from the audience after that. And our second speaker is Mike Griffin, Mike is a former NASA administrator. Mike's going to talk, well, Mike will talk about what he wants to talk about, but what we have him to talk about is the administration's direction with NASA and where he sees the most potential for future missions. Thank you, Mike.
Thanks, Tommy. I'll try to be a team player here. Before I start, however, I cannot, in good conscience, proceed without taking a moment out to the side. I want to recognize somebody in the audience here today without which you wouldn't have those nice pictures of the Saturn V or the Space Shuttle, the movies that we just saw. George, if you would stand up, please. George Miller. George was the associate administrator for what we then called manned spaceflight. What we then called manned spaceflight, politically incorrect now, during the Apollo, the Gemini and Apollo era. And without his contributions, we wouldn't have had the space program we had. George was uniquely talented. I honestly feel that much of what I learned about how to manage large organizations came from watching what George did as a very young man, reading carefully the lessons that were written down and corresponding with him and meeting with him as my career matured. So to the extent that I had success as a top-level manager for more than 2 decades, a very significant part of the learning that allowed me to make new mistakes came from the lessons that George provided. So thank you. To my comments today, we have, I think, an authorization bill that on the table in 2010 that is way better than any of us expected in the summer of 2010. It tells NASA to build a multi-purpose crew vehicle. It tells us to build a space launch system. It specifies that it shall be capable of at least 130 metric tons. It's way better than we might have expected a year ago, sitting right here today. Now, I'm often asked for media comment, well, you know, first of all, why is Congress specifying what the launch vehicle has to do? And of course is, well, if NASA won't come to the right answer, then if you have to leave it to Congress, then I guess you have to leave it to Congress. And then I'm often asked, well, why are we building a launch vehicle without a destination? And the answer to that question is, well, we actually do have a destination because the 2010 Authorization Act specifically endorsed the goals of the 2005 Authorization Act and the 2008 Authorization Act, both of which told NASA to prepare to return to the moon and establish a permanent human presence. And oh, by the way, asteroids are on the list. There's nothing wrong with that. But the primary goal was the moon. The Congress passed that bill. The President signed it into law, which makes it an act. So today, when you hear that we don't have a destination, that's just Washington's spin. We have a destination. It may take a subsequent presidential administration to recognize it, but we have one. Moreover, I have a news flash for you here in Huntsville. If you want to go to the moon or anywhere else, you need a big rocket. There are arenas in which size does matter. We have spent at NASA, since I was a young lad, uncounted hours of analysis determining how big a big rocket has to be. And here's the facts. If you want to get outside of Earth orbit with any sort of a useful crew, the rocket has to be capable of a minimum of about 130 metric tons in payload capacity. That's just about what the Saturn V could do, and that was the minimum to put a couple guys on the moon for a maximum of 3 days. Anything less than that, I would frankly say, is not worth bothering with, and if we can't do better than that 50 years after Apollo, then we ought to just all be shot. So when the Congress set a floor for what the new space launch system should be able to do, it was a floor that was very intelligently set based on decades of engineering analysis and ample expertise. So when people criticize, in this case, the Congress for engineering a rocket, well, I'll only say someone needs to. So whether or not the present administration recognizes an explicit destination for human spaceflight beyond the space station, whatever destination should ultimately be selected to be first by a subsequent administration, whatever destinations we pick will need a rocket capable of at least 130 metric tons capability. That's what Marshall is in charge of. The program office is at Marshall. It's well located here. We're not going anywhere because of the time lags involved. We won't be departing Earth orbit again until after the next president takes office, until well after the next president takes office. I wish it were quicker, but it's not. So the choice of destinations is a matter for subsequent Congresses, subsequent presidents, but what's not a matter for subsequent teams of people is the fact that we're building the rocket we need to build in order that our successors can go wherever they might want to go. So we're doing the right thing for the future, no matter what that future is, and I would just have you all know that. Thank you.
Thank you, Mike. Our next speaker is Steve Cook, Director of Space Technologies at Dynetics. And Steve is responsible for leading Dynetics' effort into space, including microsatellites. He worked for NASA Marshall Space Flight Center for 20 years, where he managed Ares 1 and 5 exploration launch vehicles. And Steve is addressing the existing capabilities that have already been funded, and he will address how NASA can move forward with leveraging an existing technology and engineering and other duties as assigned. Steve?
Thank you, Mr. Mayor. And I really appreciate the opportunity today to talk to you about where are we on SLS, from the fundamental capabilities that exist to the progress on the hardware that's been made. And I want to share with you a little bit of that progress. And I know for those of you who know me, me using PowerPoint slides is a shock, but I'm going to attempt to do so to give you a good idea of just the amount of progress that's been going on. I have another news flash. Mike talked about news flashes. Another news flash is that SLS, in its parts, has been underway for well over 6 years. The reference design configuration that you see behind me is what NASA has said is their reference design configuration for the Space Launch System. It's capable of 130 metric tons. It uses a core stage that's 27.5 feet in diameter. It uses either Space Shuttle main engines or RS-68 engines, both with good heritage and are flying today. It uses 2 5-segment solid rocket boosters, at least in its initial configuration. And it uses a liquid oxygen, liquid hydrogen upper stage powered by a single derivative of the Saturn V J2 called the J2X. Well, that concept is nothing new. This is the same concept that NASA recommended to the President and to the Congress in 2005 as the baseline vehicle for human exploration for what was then the Constellation program. The good news there is a lot of progress has been made, and frankly, physics doesn't change in terms of getting this problem done. It's a very robust approach that allows you to evolve, get more payload over time, and a lot of work has already been done. But key elements are already being manufactured today, being tested today, almost as we speak, in terms of what goes on. And what I'm going to show you is really a testament to the hard work of NASA and its contractors in the last few years and the progress that's been made. So the bottom line is there's already a great deal of work going on. It's a matter of tying the official decision to move forward with an integrated system and getting on with the program. So let's take it a piece at a time. Next chart, please. So let's talk about the upper stage engine. That's the part up there at the top that powers us into low Earth orbit and then to other missions beyond low Earth orbit. Next chart. So this is a picture of the J2X engine last spring as it was getting ready to be installed down at the Stennis Space Center into the A2 test stand. Pratt & Whitney Rocketdyne has done an outstanding job on this engine. We went to them in 2006, made a change in the engine we were going to do, and said we need to be able to bring back that engine, and we need to make it effectively the second highest performing engine in the world in terms of its overall specific impulse in that thrust class. And that's an impressive feat to be able to do something that's 448 seconds of ISP guaranteed with 294,000 pounds of thrust. That's a tough challenge. After several earlier tests with the turbo machinery, that engine was installed in the stand. And next chart, please. It's a whole lot better in a video, trust me. But just a little over a week ago, NASA conducted a very long duration test of this. Now, they're working their way up in time. I think this was about 30 seconds roughly in duration, and the engine is performing marvelously. This is a key to any beyond low Earth orbit architecture that we're going to pursue, and this engine is real, it's been built, and it's being tested. Great progress. Let's move on. This is another test stand that was installed down at Stennis Space Center. It's called the A3 test stand. This is the largest stand in the world capable of vacuum testing large cryogenic engines. There are a couple other facilities that exist in the world. Most of them are out of service. We made a decision to go with this several years ago. Jacobs Engineering is the contractor on this, and this is just an outstanding feat of technological innovation. This stand stands about the height of a football field and actually can test up to a total of about a 1 million pound thrust engine if it's ever taken to an extreme in terms of what it does. Eventually, the J2X engine will go in this stand and demonstrate its full range of capabilities getting ready for flight. Another great piece of engineering that's been done in just the last several years. Next chart. So let's move to the liquid stages. The liquid oxygen, liquid hydrogen stages known as the core and the upper stage. Next chart. So one of the things I want to talk about is when we talk about stages, we tend to focus on the big structures and the tanks and the things of that nature. The picture you see here is all of the work that goes into the brains of the launch vehicle, or what was known in the Saturn era and what we rechristened the instrument unit on in the Ares program and for SLS. This is the avionics systems, the flight computers, the batteries, the integration laboratories to put all that together. A lot of that exists. We're testing batteries today. NASA's testing flight computers today in its laboratories. It's got a laboratory set up to run all kinds of various scenarios through flight testing that even ties into actual flight hardware using thrust vector control systems. This is going on right here at the Marshall Space Flight Center right now, something you often don't hear about, but it is critical to a successful development of a future launch system. Next chart. Now, big tanks are pretty cool, though, and this is building 4755. This is what I would call a mini full-scale production facility that's got all of the tools required between this and a couple other facilities out at Marshall to build a full-scale space launch system, the cryogenic tankage associated with that. We made a lot of investments over the last 5 years in what's the largest robotic welding tool in the world, actually in the free world at least, in terms of putting together tanks up to 40 feet in diameter. Being able to assemble those domes, being able to weld them together into full-scale structures and full-scale tanks. That exists right here at the Marshall Space Flight Center and is being exercised. As an example, next chart. This is what was called the Common Bulkhead Manufacturing Demonstration Article. One of the tricky challenges that Jim Chilton and his Boeing crew and the NASA folks had to take on is we mandated the use of a common bulkhead between the liquid oxygen and liquid hydrogen tanks from a performance perspective. It's been done before. It's flying today on the Ariane 5. It flew on the Saturn 5 in both the S2 and the S4B stages. But we hadn't done this in this country in quite a while. There's a tool out at Marshall in Building 4705 that on the end of a 30-foot long span can machine to within a 10,000th in accuracy. They use to machine the honeycomb that goes between these, makes a sandwich panel between the various domes that make that common bulkhead demonstration article. And this is the upper dome getting ready to be lowered onto the lower dome. And then, next chart, they put those together and you get a core piece of the stage. This was critical because this is the critical path on the structures to get this program done. Very difficult challenge. And the next chart, you see it when it's all completed. And the next chart after that is what it looks like when you take that down to Marshall's other facility down in New Orleans. The Michoud Assembly Facility, significant investment has gone in down there to have the operational version, the production version of those tools that you saw here at Marshall. Following a model that Dr. von Braun put in place decades ago, where Marshall could build early development hardware here, flesh out the issues, have hardware close to the engineers, and then once it's ready, you take it down and you manufacture it. And this manufacturing capability that Boeing is operating down there is for another manufacturing demonstration article that they recently have produced. And this is one of the largest robotic weld tools in the country. They call it Universal Weld System 3 because they've got three separate platforms on which you can put these very large structures together. So again, a lot of capability in place, and that capability is being exercised today. SLS is not a paper rocket. Next chart. This here is some of the local capability we also have. It happens to be at our company here in Dynetics that we worked for NASA and Boeing, putting in place a state-of-the-art propulsion system fabrication capability. Didn't exist here before, exists now, with the ability to have clean rooms, orbital tube welding, several things like that. That's here in place, in operation, being used. Again, not a paper rocket. Next chart. And then finally, this is some of the testing that was done on the small solid rocket motors that go on the side of the upper stage to sell its propellants as you get ready for staging. And there's been quite a few tests that have gone on out there. Yes, there's some fire and smoke that still goes on here in Huntsville. It doesn't all go down at Stennis. And this was just a great, this is work that was done in-house at Marshall, teamed with the Army. Next chart. The core stage engines. By the way, all of the tooling that I just showed you is equally applicable to the core stage or the upper stage. So a lot of that's already gone in place for what was the upper stage can now be used for both systems as we move forward. You've got to have a rocket engine to power the core stage, and NASA has those too. Now it's got to make a decision. Next chart. Between two venerable systems. The one on the left, of course, is 135 flights under its belt. The Space Shuttle main engine. It's a workhorse, high-performing engine. And the one on the right is the RS-68, which powers the Delta IV, which we know is built right here in Decatur. So those kind of decisions are going to be made in the near future, so NASA can move forward. But either one has got flight history, flight heritage, and it exists today. Next chart. And then the booster stage. And I'll end up on this because you got to get off the pad and need a lot of thrust to do that. So NASA has been testing, next chart, with ATK out at Promontory, Utah. This is DM, what was Development Motor 1 and Development Motor 2. In fact, my last day at NASA is the day we test fired the top picture 2 years ago. The bottom picture was just a year ago. And next chart shows DM3, the third development motor, which will be fired if all goes to plan in about less than another month. That's testing out this system, which is critical, again, for getting us off the pad and getting this program running. Now, NASA is looking to also look at advanced options for this down the road, and one of the options for that might be the mighty Saturn V's engine, next chart and last chart, which was the F1. So even when we talk about new liquid boosters and things of that nature, NASA's got heritage and history there, and we've just demonstrated the ability to restart a line that was idled some 40 years ago. That capability's there. We know that engine works, and it had a very successful track record, and it works marvelously on things like this. The bottom line, Mr. Mayor, and for the audience is, again, this program got started really 6 years ago. Hardware has been progressing, and it's a testament to the hard work of all the men and women that are working today to make these things happen. And it's going to make the job a whole lot easier once the program gets an official start and can wrap the integrated program around it. Thank you, sir.
Thank you, Steve. Our next speaker is Jim Chilton, Vice President, Program Manager for Exploration Launch Systems at the Boeing Company. Jim describes himself as the person who runs the space business for Boeing in Alabama. He joined Boeing in 1984, and his experience with Marshall include the instrument unit, avionics, and upper stage production of the Ares 1 crew launch vehicle and the further heavy lift configurations. And Jim is going to talk to us about the cost. Jim will cover the differences he sees in the SLS compared to the previous programs. How could we get into a program? What does the industry need to get started? And will this help stop the brain drain that we're seeing right now? Jim?
Thank you, Mayor, and thank you for the invitation to speak. For my colleagues here on the panel, it's a privilege to be up here and a little bit difficult to go after those first three. So I'll try to lower the bar for you, Shar.
Appreciate that.
So I'm often asked, as the mayor said, what's different about SLS? And I'd like to get a little bit North Alabama-centric if I could. I've got 4 children here. Boeing's been here a long time, built a couple factories here, and I think it's important in this audience, sometimes get a little focused on Marshall and North Alabama. So I'll talk about Space Launch System and what I see that's different about that. First and foremost, I think we have to recognize that the Marshall Space Flight Center is being tapped on the shoulder to lead a program and not a project. And that's a little bit technical in NASA speak, perhaps, but there's a big difference. And in fact, it's probably going to be one of the 2 or 3 largest programs in the agency if it happens as contemplated in the Authorization Act and with NASA's design reference, the public data industry person could see. You might say that's not a big deal, but I think it will drive some behavior changes among us as stakeholders of a program. As a Boeing leader, I can tell you with the space business, I enjoy typically between 275 and 300 space station employees that work here in town, often out on the Marshall Space Flight Center. And that space station program is actually headquartered at the Johnson Space Center. So what you often see, which might be different for a program, is, Mike could probably confirm this, that the administrator of NASA is going to expect that not all the work in a program stay exactly at one center. So we're going to have to take a little bit different view. Now, believe me, I'm not a proponent of moving a lot of work out of town, but I think we're being asked to step up our game and behave differently as stakeholders. So we're going to have to make sure the program is very successful and focus on outcomes, make sure it works, in addition to the kind of advocacy we've done and being strong stakeholders for our own interests in town. And I think that's not a negative thing. That's something we need to do to help Marshall. We all need to keep that in mind and probably behave a little bit differently. So that's a big one in my view. The second one, what's different about SLS, and I'll assert this, I'll watch Phil Summerall's face. It's like getting your paper graded, sitting up here looking at him. I think the agency, if they pick that design reference vehicle or something close to it, trade a few things around, they're going to know more about the technical baseline of this product than probably any program NASA's ever launched or commenced. All right, so in my view, that takes a bunch of risk out of it. Now you could argue, do you like what you start with or not? That's fine. That debate, frankly, is above my pay grade as a person in industry. But I don't think we in town should be sitting back saying this is the scariest program to go launch. We know a lot about these devices. Agency has a lot of experience, and there's been lots of competitions and technical development around this. So that makes this a different program launch than, for instance, trying to get to the moon or launching a reusable space shuttle program, things that decades ago were huge technological leaps. We know a lot about this and shouldn't be afraid to start it. And the last thing I'll say locally about, now that you know we're going to have a program and we're going to know a lot about the device, I think we have to be mindful of our culture and how we behave going forward because of those first two. I'll digress a little. I think historically Huntsville has always had a big shuttle piece of work. You know, if I look at Marshall, and then we've always had sort of a running series of other programs. And many of those other programs never got deep in their production. They were technology type jobs, maybe got to preliminary design review. They spun off into other products in commercial industry, you see some of that. But there's always been shuttle, which is operational, and then something at the very front end, and a lot of great science and technological work. And so we're going to enter a domain that's in between those two. And we really have to behave a little bit differently. We got to respect the value of the day. We have to understand that sometimes you're going to face a development problem and you're past the trade study point. You don't get to back up. You're just going to have to put the throttle down and deal with it. Get yourself into test and move forward. I'm being a little detailed, but I think those things are cultural. And it'll be inherent on a lot of us in the agency and in industry to make sure our teams are ready to behave in that way. Now, the mayor also asked, when I get asked, what does industry need to get started? We're ready. In fact, I think we're past ready. As a Boeing leader, I can tell you we've invested in the technology. We've got a team on the field. That team's in North Alabama. You know, my answer there is put me in, coach. Now, that said, I want to give a caution. I know I'm thinking about this a lot, and I'm sure my colleagues in industry are. We're at a point where NASA has a plan, but they haven't shared a lot with us. We need to be mindful not to look backwards, at least managerially. NASA has done a lot of work to ask us, how can we operate more efficiently? What can they do to have different types of business transactions or operate differently so we can get a better cost? And I anticipate when they roll this out, they're going to ask us, they're going to act on that input. They're going to ask us, how are you going to behave differently, and I want you to try this and this and this. And, you know, we need to be ready for that. We need to embrace it and accelerate the program rather than be surprised because they want us to behave differently. You know, I think shuttle contractors were expected to behave differently than Apollo contractors. I know personally I worked shuttle and station, and station was a different sort of development and different pace than shuttle. So we're going to be asked to flex again. NASA's going to lead us there. They've taken a lot of input from us. We don't need to do trades and debate it. They've got what we told them. They'll decide how they want it to go, and we're going to have to deal with that and move forward. So I think industry teams need to be ready to do things like innovate, to be cost efficient at low launch and production rates. You know, we always want to tell the government, you have to buy lots of our product for us to be efficient. And I think they're quite fairly going to ask us to try something else, try a different speech on them, and we're going to have to innovate around that. Finally, you asked, will this reduce some of the drain that's going around Huntsville to some of the critical jobs that some in industry we feel we've lost? Yes and no. Yes, launching this program and addressing these cultural issues will create jobs and a great buzz and keep our legacy and our future alive. But I also think when you look at deficits and consider Congressman Cramer's comments, we're going to be asked to be leaner. So it will reverse some of the drain, but probably we're always going to be different and asked to do things differently and rightfully. So I couldn't promise you. I know Boeing tries to be more productive every year, and I'm sure all our colleagues and competitors do. You try to do your job and you try to get better at it. So in the sense that the tide could go up when we have a new program, that will reverse some of the brain drain. But in the sense that we're in a tough budget environment and we're going to be asked to innovate, we shouldn't get too sporty and try to treat the agency like it's going to be very flush and that efficiency doesn't matter. Thank you for your attention. That's what I have on those questions.
Thank you. Thank you, Jim. I think I heard several mottos in there. Either we're ready, put me in, coach. I've heard the other one of ready to go, and throttle up has been the other one. So we'll pick a motto at the end of this. Our last speaker is Shar Hendricks, the president of Hendricks Group here in Huntsville. He works with clients in the aerospace and high-tech sector and government relations and corporate communications. And Shar is going to discuss why this effort is so important. What does this program really mean for the United States? And aside from the economic issues, why is it important for us to move forward with SLS and, more importantly, to have a robust human spaceflight program? Big area to cover, Shar.
Thank you, Mayor, and thank you. I'd like to also recognize Mayor Battle just quickly for not only pulling this panel together, but also spearheading a group to really pull together and marshal the resources of this community to project and tell the SLS story. We think that's, I mean, it's very important, it's very critical, and Mayor Battle's taken a leadership role in that, and we appreciate that. Couple things. One of the items I was asked to talk about is a little bit about morale issue and where the community stands right now vis-a-vis the morale of the workforce and where we've been. Of course, as you know, by keeping up with the press, it's been a tough cycle. We've seen a lot of talented colleagues that have lost jobs in this situation, but that can be changed, and it can be changed very quickly. And there are really two pieces to that puzzle on morale. One is getting a mission started that is tied to a national purpose and that has a clear set of mission goals, and SLS certainly provides that. And then the second piece is the resources to accomplish those goals. So once we get that in place, and we're getting closer, I think you'll see the morale and the focus of this community respond in a very positive way. But the second piece of that is, and it was brought up one day, we were having a session or meeting with the mayor, and we had a prominent businessman here in the community that was with us, and I think he asked the question to really challenge us, because so many times we can get kind of the technical aspects and where we are from a programmatic standpoint and budget and schedule and where the money is and that sort of thing. And he says, you know, why are we doing this? Why is it important? we can't ever stop explaining the human spaceflight piece of this to the public. And so let me just talk a little bit about that. Interestingly enough, a couple years ago, in fact, it was Dr. Mike Griffin's group over at UAH held a workshop on developing a sustainable human spaceflight policy. And out of that, some interesting data was brought forward. Since the establishment of NASA, there have been no fewer than at least 24 reviews of the purpose of human spaceflight, what it means, where we're headed, why. So this has been something that's been thought about quite a bit. Let me just give you some of the rationale and reasons that we often talk about with human spaceflight. First of all, from a pure exploration standpoint, it's part of the national character. Going back to Lewis and Clark and the whole idea of manifest destiny, the idea that we as human beings, and certainly as part of the American fabric, have always had a desire to push boundaries, to explore. There's also the international leadership component. Great nations do great things. And a part of that is tied to economic competitiveness and global economic competitiveness. And clearly we see there's a historic connection between opening frontiers and being able to reap the economic benefits of opening those frontiers. Space is no different in that aspect. So that's another piece of the puzzle. The other piece that's often talked about is national security. And what I would encourage you to do is think about it from national security in the broadest sense of the term. In other words, our nation has a tool set in the national security arena, sticks and carrots. Clearly, we often think of the military on the side of their capability and what they can project of U.S. force, but there's also the national security through international cooperation, and certainly NASA and the space program is an area where we have been able to encourage and work cooperatively with nations to demonstrate capability and technical prowess, and that has always reaped benefits for the nation. It's just simply that ability to demonstrate technology through peaceful means. Another aspect is inspiration. We heard, actually, I thought it was interesting in the loop that preceded us, there was a discussion, the guy, one of the people that was interviewed used the term of building monuments. And that's exactly, really, it's that ability to build a modern day monument and what that means from an inspirational standpoint. You can't sit here in the U.S. Space and Rocket Center, home of International Space Camp, without thinking of the ability to inspire the next generation of explorers. And prior to going out and establishing my own company, I did work for NASA for 9 years in the External Relations Department and office at Marshall Space Flight Center. And had a chance to talk to a lot of people from a lot of different backgrounds on what the space program meant to them. And it's interesting to see people in very challenging careers, from medicine to perhaps engineering, across a wide array, whether it's defense or industry, first got inspired to tackle hard subject matter, to take the hard classes, so to speak, through inspiration of the space program. Seeing what it meant to them and understanding that, great things take a lot of dedication and effort. So that is definitely a piece of what human exploration in space is about. And then finally, I would suggest to you that another driving piece is science with the human in the loop component to it. Oftentimes there is an attempt to drive a wedge between those within NASA or those within the space community that favor robotic exploration versus human exploration. And really that's a false trade to begin with. And I would reference Steve Squires, who's the principal investigator for the Mars Exploration Rover project, who's time and again talked about the importance of human exploration and has noted that with all of the accomplishments of the Mars rovers over the past several years, that a human presence on Mars could have done that type of research, an amount of research within a matter of weeks. And so you begin to see that the human in the loop in the science and science discovery is an incredible piece of it. One of the things I think we've kind of made a mistake in personally over the years is as we begin to look at these and the other myriad of reasons and rationale that we pursue space exploration, we tend to want to drive it to an answer. You know, what's the bumper sticker? And what I would suggest is that this resonates with people on different levels. And I think we ought to understand that and be comfortable with that. I think that there are people who will always see the human in the loop science component as the most pressing need for human spaceflight. Others will see it as an issue of national prestige. I think those are all valid reasons, and we need to understand that and put it in the total context of our outreach efforts to explain and talk about this to the public. Finally, I would say that, when we talk about SLS and the reason for big rockets to do big things, it's always, that ability to push a boundary and to set the stage and to go beyond where others go is an incredible part of what we are and our legacy. So I applaud efforts to bring down the cost of access to space and create a cheaper way to get a pound of payload into orbit, but we've got to move beyond low Earth orbit. And that's what the Space Launch System provides us. Finally, I'll just close with, again, by also thanking Deb Barnhart, our host today with the U.S. Space and Rocket Center, and to just salute her great team, because when you talk about communicating the importance of space, this is a team that does that every day here at the U.S. Space and Rocket Center, and not just on a regional or national level, but clearly on an international level. It was a great story last week about students from around the world that have come to Space Camp this year. Just a fantastic outreach tool and motivating piece. So thanks, Deb, for that. Thank you, Mayor.
And I'd like to echo the thanks to Deborah Barnhart and the Space and Rocket Center and all the crowd here who has put this together. Deborah gave one of the most classic examples of why we need a space program last Saturday night. And anybody who missed it, you need to talk to her about it. She brought up a young child who had just finished with Space Camp. And they had dreams of being an astronaut, and they were going to go home and study their science, their technology, their engineering, their mathematics, and so that they could one day be an astronaut too. And she does that with how many students per year? 100,000 students a year. So congratulations, and thank you for the job that you do for us. We have about 7 minutes left, which means with this group, probably time for one question and then a wrap up. Who's got the lucky one question? Harry.
We have had an excellent presentation on how we can get to go where we want to go. How do we reach a few cities, especially how do we sell the mission? The mission would drive the authorization to go forward. We haven't, it doesn't seem like we put as much emphasis on getting the mission as we have presenting the fact that we can get
The question is how to sell the mission, and Mike is going to wrap us up with that and his final statement. Mike, would you take care of that?
Well, I will. I have to say, we need to be realistic. We're not going to get a new mission prior to best case 2012. This administration, I need to take the fuzz off things. This administration does not want the United States to have a human spaceflight program. I'm going to evoke Mark Twain. If it looks like a duck, quacks like a duck, walks like a duck, it's probably a duck. Now, what do I mean by that? If every single action having come out of the administration in the last 30 months works against having a NASA human spaceflight program, and no action taken works toward it, except those done under protest when Congress passes a law and they're trying to evade that, then the only conclusion you can reach is that the administration, which is not stupid, these are not stupid people. I disagree with them, but they are not stupid. The only conclusion that you can have is they do not want NASA to have a human spaceflight program, irrespective of what political pontification may occur. I think Gallup poll after Gallup poll after Gallup poll shows that 75% of Americans want to have a human spaceflight program. When they think of NASA, they think of human spaceflight. Well, they should. So this administration is not going to wake up tomorrow morning and say, oops, we made a mistake. They're going to keep saying what they think Americans ought to want instead of what 75% of Americans do want. So that will change in the future at some point. It'll change in 2012 or 2016, I don't know which. It's our job, as the Congress has seen appropriately, it's our job to continue with the building blocks so that when somebody does say, you know, I want the United States to be on the frontier, we're not starting from scratch. There is not a realistic hope that we are going to get a, quote, mission, unquote, again soon. There's just not. And so what we need to do is be planning our affairs as a community of spacefarers such that we retain, recover, keep the most that we can keep, and be ready to go when somebody says, you know, I'd like to go. The reason why Deborah sees 100,000 students in space camp in Alabama, okay, in the United States, is because we went to the moon. What I'm worried about is when 100,000 students want to go to China because they went to the moon.
Thank you.
Not right now. I'll just then close by saying there are some plans which are so stupid that you know that that plan will not come to fruition. You may not know what actually will occur. Right now with the U.S. space program, we don't know what will occur. What we know will not occur is the plan that this administration has put on the table because it doesn't pass the sniff test. You will not change their mind. The Congress is not trying to change their mind. The Congress has carefully written a law. Regrettably, people don't go to jail for failing to obey this kind of law. The Congress has written a law, and the question is whether the Congress can compel the administration to obey the law. You can't compel somebody to want to have a human spaceflight program. So let's do what we can do for the next few years. And that's what today was about. There's a very carefully laid out program on the table for what we can do, and it's all good. It does not require knowing a destination to know that the plan which has been put on the table with the Space Launch System and the multipurpose crew vehicle is a good plan. It doesn't matter where you want to go, you need what we're building. So let's just get busy and build it and wait and bide our time.
I'd like to thank the full panel for coming out today. I think we come away with the mottos of we're ready, ready to go, or throttle up. Thank you for coming out, and thank you very much for your participation.